Hi, everyone. Thank you so much for being here. Daniel covered a lot about vector search, and that was like a big part of what I was planning to talk about. So now what I'm going to do is go a little deeper into the challenges that he already started talking to you guys about. So hi, I'm Vishakha. I'm the co-founder and CEO of ApertureData. And yeah, we have built a database specially for multimodal AI. And let's go see what that means, how we came about it. We started working on it back when my co-founder and I were at Intel. So yeah, it's been some time trying to figure out these problems and experience all the things that he talked about. I just didn't answer his questions because that would have stolen the thunder in my talk here. All right. So let's talk about building the right data tools for multimodal AI. And I always find it easier to start with some use cases. And I'm going to start with a more traditional machine learning sort of use case. So, we've been working with a visual AI team with an e-commerce vendor for quite some time. And the biggest thing is can we recommend products that will make customers want to buy? And our buying habits are more visual. Like you look at something, you like the color, shape, pattern. But it's not just that. You want to recommend products from the recent catalog, and then you want to show the actual images. So the first part is finding similar by color or shapes or patterns or anything. But then you have to go constrained by, okay, I only want fall 23 catalog. And then you access the image. So there's the vector search, followed by the metadata, followed by the data access itself. And even before people can get to that, we are talking about indexing all that image data, creating the embeddings out of the images. In fact, before you can index the embeddings, you first have to train the models on your catalog so you actually can create embeddings that you care about, or in this case, these guys had to care about. And then you index the embeddings, you correlate everything together. So that's one use case. The other one is the use case that we have all now been coming across, chat support sort of use case. So what does error XYZ mean? What does it mean for equipments made between 2022 and 2023? And anytime you get the manual for the equipment, you want to limit it to manuals authored by Team A. And you want to see the manual, of course. So again, we are talking a real-life problem with similarity search constrained by metadata filtering and followed by PDF access. So you see the theme of where I'm going with this. So in general, you need the ability to index and search over high-dimensional embeddings from any number of multimodal data types. So it's not just text. It can be text, images, videos, PDFs. And then you want to combine it with metadata filtering and retrieving the corresponding data. And not only that, when you are deploying this in production and you're doing this at scale, you need high throughput, sometimes low latency. The metadata is constantly evolving and often very rich. It's not just one or two columns. It's a whole sort of relationships, and we'll see some examples. You want to be able to get to the original data because you're doing all this search to find the data you care about. And you want this reliable, scalable, and if you're working, particularly in a big company, there's all these constraints around, enterprise ready, cloud agnostic, can it be deployed in your virtual private cloud? So these are all the requirements we are placing on the data layer. But if you look at and I think this is something that we all just saw, vector databases today, they'll let you store the features, they'll index them, they solve a very complex problem. And oftentimes you can attach some metadata to each vector. But most of the times you have to carry the ID around to correlate it with your original data and any complex metadata. So you're missing complex graph-like schemas, which is what real applications end up having. You're missing the capability to manage the multimodal data itself. And it's rarely built to integrate with the overall AI pipeline. AI pipelines don't just start and stop at LangChain or Llama index sort of level where you're just querying the data. They start from the point where you collect the data, index the data, curate, sometimes label, and they go, and that's when you come all the way to the query part. And not to mention all the choices you have to make around whether it's cloud, which cloud it's supported on, is it scalable, can it support all my enterprise requirements? So what do people get today? And I think this is going to be a much uglier picture of what we saw in the previous talk, because what you start out with is, data input. It can come from, your own assets. You could be recording constantly from sensors. And what you really want to get to there is on the side. You want models to deploy. You want data to show. You want to see, you want to do recommendations or build LLM and RAG-based applications. But your data backend choices suck. You're going to ingest the data, typically put the large files into cloud buckets or some distributed file system. You're going to pick one of the databases to put your metadata in. If your application requires some form of labeling, you're going to be dealing with, how do I pull my data out? How do I land my labels in? How do I make them searchable? And that's when everyone in the different teams will be writing their queries to pull information out of these different pieces. And God forbid, if you're working with image video type of data, to bring them in the format you can use them, very often you have to work with hard to install and hard to use computer vision or audio processing libraries. And then after that is where you get to the stage where you have your embeddings that you can index in the vector database. So what really ended up happening, even if you were choosing the right tools for the right data types, because of the problem we are solving with multimodal data input to produce human-like AI output, you end up with this spaghetti-like solution, which, as you can imagine, is a pain to install, awful to keep up to date and maintain, and really, really painful to debug when something goes wrong. And that's why people end up spending so much in their resource cost. There's so much lost opportunity cost because you spend so much time assembling this. And then when you get into enterprise problems, data governance becomes a problem. Now, dare I ask how many of you have actually felt this sort of pain in trying to set things up? Thank you. A few. But that's where you're headed if you're deploying AI in production. So how do we solve the problem? So what we realize is really at this point, we need to bring different data types together, which means you need something that understands the complexity of data management and the requirements of AI pipelines. So first thing we addressed was the data itself. So, ApertureDB allows you to manage multimodal data. Why did we not leave this in cloud stores or file systems or data lakes? Because this is what you get. If somebody wants a specific data set, they will go download it on their specific local machine. Then you start losing track of how was that data processed? Where was it downloaded? How many times was it downloaded? How much storage is it occupying? Sometimes you may have permissions, sometimes you may not have permissions. Is your machine powerful enough to create that data set locally? And so ultimately, if you are using and trying to use all this data for producing good AI, the outcome is really subpar. And so, and this is text-based. Imagine the pain with images and videos. Then the second thing we realized is the metadata in a lot of real-world applications looks like a graph. However, graphs used to be slow because of all their connected nature. So that's why we decided to go with a memory-optimized property graph that we built back when we were at Intel, and then we had a second version during our time in the last couple of years. And why did we go with a graph database? Let's take a look. Typically, this is just like a claims and insurance sort of example. There is freight connected to the carrier, the claims they are making. All of this information is connected to each other. And the queries tend to be, okay, well, I want to find all the freights managed by carrier named Trucking 409. And most of these things have, in your relational databases, you'll do foreign keys. In key value stores, you'll really have to bend backward to represent all this information. Then let's take another example of retail. The customer walks into a store, you have cameras recording videos and stuff. Maybe you have interesting clips that you want to find out. When did someone pick up a cereal box? Maybe you want to create data sets that later on you're going to use to train your models. We looked at a lot of real-world applications, and the schema invariably was in the form of a graph. So our thought was, if we can make a fast, scalable graph, that would be the right database for storing the metadata. And that's what we did. We built a new graph database, low latency, scalable to billions of objects, and high throughput to integrate seamlessly with ApertureDB. Then the last big piece was vector search. So we started working with images and videos first. And so one of the ways of finding this sort of data was through embeddings or signatures. And so that's why we built a vector database with it. We introduced it's based off of Meta's Face library. So it has a flexible API. We support different indexing algorithms. And as of some customer measurements, we are 2 to 4 times faster in the way we built this. So putting all of this together, we didn't want users to actually have to talk to multiple solutions. So that's why we built a query engine that unifies all of this. So as users, whether you are querying the metadata or doing vector search or fetching the data, you're talking to one system with a one unified query language, which is why we actually let go of SQL interface and we built a query language that we define because we wanted to combine all these different artifacts seamlessly. And so that's how we give you a unified backend for multimodal data. You can do different searches, data management, and then you can work on different. So essentially what we really want to do and what ApertureData brings differently is you can use all your data across your entire machine learning workflow and achieve the results you are looking for from your AI efforts. I'm going to skip some of the performance and all these things, but I want to come to, the title, like, does it really make a difference? At least for the e-commerce example, a team of 10, you're looking in productivity gains about 2 million in savings and keeps growing as it grows because of the time you save for the data scientists and the access you give to them. Same way, we worked with this retail company that scans shelves, the robot scans shelves, and they are figuring out inventory. And what we were able to offer them is much faster, high throughput vector search for this application, and they have been able to scale to more than 300 stores, which indirectly impacts or directly impacts how many stores they can keep growing to. So now let's look at, did we really simplify the life of data scientists and engineers as we started, as our initial goal was? So how many of you guys here work with just text? Images, videos? Awesome. So one of the things we recently did, and I will try to switch here. You can now, we recently launched our database on the cloud. So you can go to cloud.aperturedata.io/sign up and create an account. And what you will be able to do from there is just create your demo instance, choose from one of these providers. You can start out with our free plan, and then you'll be able to run our quick start example. So what I want to show you here, so if I go on my notebook, I'm just going to activate my cloud connection. So we have, of course, I care a lot about food wherever I go. So our sample data set is based on food images. So you can, if you start the quick start from our cloud, you'll be able to just configure. I did all that stuff. I'm just going to connect to my ApertureDB instance. So we have the database that runs, and then you can do pip install ApertureDB, which will install the client. And then you can essentially import ApertureDB and some utilities, connect to the database that I've already configured. Now, I have already ingested the cookbook data set, and what it has, let me actually show it to you on our UI. It has, so if you search, it has some number of food images. So I ingested them, as you can see, with some metadata on the side and the images themselves. In fact, you can go on this dashboard and see what the graph schema for this is. We ingested ingredients, images, and descriptors is what we call embeddings. And so in this example, we have ingredients, images, and descriptors, and the relationships among them. So this is the data set we ingested. You can see the summary here. So I won't run the ingestion here, but one comment that I want to place here. What we did was we defined the dishes in a CSV file, so just all the properties you want and the image files themselves. You run an ingestion and you can apply. So in the earlier talk, we heard about clip embeddings. So that's something we run quite often. And you can run any model here that will help you extract embeddings from the data type that you're ingesting. And what that did, not only did it add images to ApertureDB, it actually added the metadata and the clip embeddings corresponding to that image to help us create a graph schema that looks like this. So we ingested in that small data set example, just a subset of this. And that's essentially the image, which is the dish that we added, the ingredient, and its descriptors. And so if I were to start running some queries, now assuming this is going to work live. Oh, it did. So what we are looking for here are, images that are from Scottish cuisine. And you did the metadata query and fetch the image from the same database. In fact, this is what I was talking to you about, our own query language. We define entities, images, objects, and then you can do graph traversals on them. I don't have time to go into how it works today. So let's just assume it's going to work. And what we are really looking for are images and information of dishes where you have butter and chicken at the same time. Now, I know we are getting closer to food time, so bear with me. This is on purpose. And so what we did was we actually we found 2 different ingredients and found images of dishes that contain both the ingredients in them. And so that's why we got this butter chicken photos. Similarly, you can now do vector search and you can say, okay, find me dishes that look similar to bread. And in fact, in this case, we are asking it a text question. We are saying, I want a photo of bread. And we are going to use those clip embeddings that we indexed. And what it's going to give us are images that match the photo of bread. And all of these actually, well, this is questionable, but that's where, but this one you can see. So a lot of it, of course, depends on the model, which we don't control. In fact, there is one picture where I look for Scarlett Johansson and I get a person, like a guy with no hair. But I blame that on FaceNet embeddings. It's nothing to do with the distance that we do. Oh, wow. See, I even missed that part. So not bad. I shouldn't blame the models just randomly. So yeah, I mean, this essentially, this shows you some of the power of how you can manage the different data. In fact, the same way that I'm doing image queries right now, we have indexed videos and you can run constraints and get videos. You can get interesting clips from the videos. In fact, you can do similar sort of text-based lookup of video clips in your data set. And the power really is that you're bringing all of these different data types together, which is where if you look at where the multimodal AI, all the work that we are doing is going, you're going to need all these different data types, and you really don't want to have to talk to 5 different tools to get them together. And so that's what we are offering with ApertureDB. In fact, if I go to my documentation chatbot, I asked it, so we built this chatbot using our LangChain and ApertureDB vector search integration. And I asked what's multimodal data. It tells me you want to combine these things together. And we have indexed, of course, our documentation and use this. So yeah, I mean, that's essentially a quick overview of what we see with the with ApertureDB. And I wanted to show you a combination. So we in another data set, we have celebrity faces that we indexed. You can search people with black hair. And this is what I meant with the FaceNet. Look at the match here. But you can combine vector search with metadata here. You can do find near neighbors, but filter them by brown straight hair. And what we are doing here is giving it the ability, using the database to combine vector search with the metadata search, which in our case is a graph, because we blend everything together in the graph that we represent things in. So that's some of the examples. There's a lot more you can do. You can integrate with PyTorch, TensorFlow. You can work with Label Studio for labeling. And these are our blueprints. We can work with other tools as required. And yeah, essentially the big takeaway here is like, when you use the right data tool, you can go from days or months of preparing data and wrangling with your data to minutes of just querying for what you need. Now, for what we would really like all of you guys to do is scan this QR code. We have a contest that's live. We would really like to see you guys go build something cool with ApertureDB, use some partner tools. We are uploading some examples soon. And hopefully next week, we are able to do some live event to answer questions. We would really like to see some neat examples that bring different data types together. Thank you very much. You can still use ApertureDB for text search too. It works with all the different metrics and engines that you need. And that's what we do in our chatbot with LangChain. And over time, if you realize you want to index more things, you already have the right database for it. That has been one of our controversial choices because people are like, why would you need anything other than SQL? And really the answer is we looked at SQL, GraphQL, Sparkle, and the problem was we were trying to combine a lot of different data types, the ability to search by metadata, vectors, and one of the things I didn't cover in the talk is how ApertureDB has these pre-processing operations. So not only can you say, find me images of Scarlett Johansson, but also say, give them to me in thumbnail size. And specifying all of that in SQL would have really required like a language guru, which we were missing at the time. And we focused more on the functionality. So we bit the bullet, said, okay, we'll define the simplest form of a verbose JSON-based query language so it's easy to follow. And we built it with that. I think this specialization comes from, like, if you look at the way we can deal with images and videos, because that has been our longest experience, and the text and stuff is, like, we've started working with them recently. But if you are working with images and videos, there are some really challenging operations. For example, with videos, sometimes people only want a little 10-second clip that's interesting, but they have to go get the whole hour video or pre-chunk it to do that. And we have ready operations that say find clip, which you get the interesting clip, but you don't create a copy of that clip. So this is done on the fly, and it's done at the video decode speed, even if you're pulling some little portions of it. So the fact that we are able to manage the data ourselves gives us the independence to do all these, like, to introduce these sort of features. The same thing with polygons and bounding boxes that we provide on images. We are able to do all that because we manage the data as well.